Do you have a 2011 MacBook Pro which has issues with the GPU causing the machine to slow down? Stick around and I'll show you a little hack that I've developed which will hopefully solve that problem. Now these machines, a 15 inch and a 17 inch, are both well known for having an issue with the GPU. They overheat and they get bad connections within the GPU themselves or between the GPU and the logic board, and they have bad graphics problems like just artifacts on the screen or booting problems, or they'll do random slowdowns where it has issues with the thermal sensing from the GPU. Now what I'm going to work on, I haven't done this before, this is a bit of an trial experiment for me, but I believe in theory it will work, is I'm going to modify the thermal sensing on the GPU. Now this particular machine, it works perfectly fine, there's no graphics artifacts, there's no booting problems, it works absolutely perfectly. But every once in a while it will slow down because the GPU thermal sensing plays up. That's the only thing that's wrong with it, just that one thing. Now we do have these devices here. You see my Zappa TICS. I did a review video on this and showed how to install one in a 17 inch a couple of months ago now. So if you actually have a bad GPU which is completely gone, or you just don't want to mess around like I'm going to do now, you can buy one of these. Right, this is where they come from. Right, so cmizappa.com, just go there. You can get them from there. They're not that expensive. They're certainly better than having a dead computer. Right, they're pretty easy to install, and I actually showed that video for the 17 inch. I do have the 15 inch version as well, obviously, because this is what this is here. They are different. This was sent to me at the same time as for the 17 inch because I thought I might need it. I may still need it yet, so if I do have to resort to putting this in, then I will show that in the video. Okay, I've actually got two of these 15 inch machines. The other one is actually slightly worse than this one as far as it will play up more regularly, which is likely this will be the one I'll probably end up putting this in. We'll see if this works first. Now, because I can't actually recreate the fault this has, it just does it randomly. It'll be absolutely fine for a week and then suddenly it'll just do it once. It'll slow down for 10 minutes and be alright again, right, where the temperature goes up. Now, let's just actually boot this thing up. A bit dirty. This is also a machine I've repaired as well. So this is one of my fixer-uppers. I fixed several computers. I think I've purchased about 14 machines all up, something like that, and I've got 5 left which are in the queue left to be fixed. 3 look like they're beyond fixing, and 2 are on the fence. May or may not work. This one does work. You'll get there in a minute. And so I'm pretty confident this will be okay. Alright, so you can see it's booting. Actually I should turn the power supply on and power into it, because why not. Now we'll let this boot up. I think I've got an SSD in this, and I can't remember. I haven't noted it. Usually I note it on the bottom of the casing. Like I've got here, got a sticker, gives me information about the unit, what I've done to it, what issues I had, that sort of thing. Come on, hurry up. Okay. What's the password? Hold on. Oh look, you can see what I'm typing. I think it's password anyway. It is password. Doesn't matter, it's not very secure. It's just I'm going to be changing this anyway. You can see I've got this hardware test HW monitor, it's called. Very handy little add-on. I'll suggest you get it. And it lists all the temperatures. So we have GPU die. It's currently 128, and airport proximity 129. Okay, so the airport proximity is another one I was actually a bit curious about being a problem. But the GPU die, that's normal, right? Because the Mux switches it on and off. If it's using the GPU, the dedicated GPU, then you'll see that will change. If I go into settings, let's try and change that now. So under energy saver, graphics switching, turn it off, and now you see the GPU is now saying 35 degrees, okay, or 33 degrees. So that's why we get that error reading there for that. Now it's not going slow normally, but when I've seen it go slow, I've dropped in, checked this, and it's been a hot GPU sensor reading. Okay, so that's like an issue. If I switch this back on again, bring it back down, and it should be back onto 128, 129. Yep. Okay, so that's normal behaviour. But so normally you shouldn't see this. If that GPU is being used, you shouldn't see this temperature go high, and it happens. Okay, so that's how to check that. Okay, so I just wanted to show you that. So hardware monitor, HW monitor, very handy little piece of desk here for diagnosing and stuff. Also got max fan control as well if you want to try and run the fans at a faster speed in order to try and mitigate overheating. So you run them so that the whole machine runs slower, but because you set the ramps to be sooner. That way you get a bit more noise from the machine, but the machine runs cooler, which just helps its lifetime prospects. Right, so these machines don't like getting hot, so I highly suggest you chuck in like max fan control and set this up so that it runs the fans a bit more consistently, so they come on sooner, and try and keep the machine cooler, just to help reduce the chances of that GPU failing. Okay, so you can see it's a perfectly working machine. Okay, now airport proximity, I've seen the same sensor coming up on other machines as well, the same like 15-inch model, so it's probably just a thing which doesn't really matter. So you can see it here as well. I've also got temperature sensors in here, and it's not showing up at all on here as being a problem. Let's shut this thing down. I'm going to show you this little modification that I'll try doing. And you have to make sure you turn power off and disconnect the battery and that sort of stuff. So, you know, that's something you need to make sure you do. Right, so I'm going to show you what I'm talking about here with this modification. Now, this is part of the circuit diagram for the 820-2915, which is going to be very similar across other models as well, like the is it, I don't know, the 17-inch, whatever that one is. I can't remember what it is. So this is the device here. You've got a U55 or 5550, which is the actual IC, which is the EMC1414A, which I'll show the data sheet for in a second. And we've got two inputs on this device. Now, one is for the fan stack. There's two sensors there, which I pointed out before. One sensor here, one sensor there on the fan stack. So you can see that it's just using transistors with the diodes, internal diodes on the transistors, right? Diode junctions on them. And this is the pair which go to the GPU, which detect the die temperature. And this is let's call it an anti-parallel system, so they're back-to-back junctions, whereas this is only a single junction, so therefore can only do one sensor. So there's C5551, which I attached the sensor across, and you can see that's what it's doing. Now these are inputs to this device, which then jump on the SM bus, and off they go. Now, considering how small this thing is, it's actually got a massive data sheet. So that's the circuit diagram. So we'll move that out of the way. Now we've got the actual board layout, so I'll show you a bit more closely what I was doing. So here's U5500, there's that capacitor. Now what I did find is in this board layout, there are some errors, like there's missing connections. So C5501 should have two connections, one going to pin 2 and one going to pin 3. And this one says no connection. And pin 3 doesn't go to it, right? It does. It's an error on the diagram. And the same for C5552. That goes to pin 4. This one's supposed to go to pin 5. It doesn't. Pin 5 showing no connection, which isn't correct because that actually comes to here. Right, and then goes off to everything else. There's some missing connections on this device, so watch out for that if you're working on these units. You do get errors like this from time to time in these board layouts. Yeah, you work with what you can get. Okay, so that's that. Now, next thing. This is the data sheet for the device, and it's got a lot of pages. I haven't counted how many, but it's got a lot of information here. If you ever try and figure out how something works, always put a data sheet up. Let's just look at the actual block diagram for it. There you go. Give you some idea. So these are the inputs over here. Those are outputs, kind of. Thermal dressing. I don't know. I haven't looked into that side of it. And that's the data, inputs and outputs. Here, there's also a clock coming in. So this is what sends data to the SMC to say what's going on. Right. So let's scroll down. These are the device types. And if we look down here somewhere, I'm not going to look for the data stuff. These are some examples of the diagrams. So CPU or GPU thermal junction. It's using a PNP. I'm using an NPN. Probably doesn't matter. Here it's using NPNs on that second input there. Probably doesn't matter. There's another one here that's also using a PNP. But as you saw, I just made sure I had the same polarity. It should be fine anyway. And it's given these examples of the diode connections for DP1. So DP1 and DP1 DN1, which is that single pair which I was looking at. They can be PNP or NPN. PNP is tied to ground through here, through the device, and the NPNs are not. Now, one difference between what I've done and what this recommends is it's got the collector and the gate linked together. I haven't done that. I'm just using the diode junction between the emitter and the base. Whether that matters, I don't know. I guess time will tell. I may find that it's an error and I might have to link them together. If it misbehaves, then I'm going to have to do that. If you try this modification out yourself and it doesn't work properly, please comment down below. Or if you find a better way or something like that, I don't know. So here we go. 2N3904 is what was recommended. Right? Well, an example device. And this is the anti-parallel system which is got for the fan stack on this particular machine as well. 2N3904 is recommended. Alright, so yeah, and it's got heaps of data in here about configuration of data buses it uses. It's just a massive data sheet for such a small device. It's incredible, really. Right, so it's taking all the screws out, as you can see. Let's put the cover off. And here we go. It's the inside. Now, let's kill power. And pop the battery off. Quite important. Mustn't have any power on anything whilst we're doing this. Now, what I'm looking at is over here. There's a chip right there, which is the sensor collection chip, I suppose you could call it. I don't know, it probably has a proper name. But that little chip there communicates with the SMC and the system, telling it what temperatures are of the GPU and the things, the ducts as well, the sensors for the ducts. There's the sensor over here, and another one over here, just there and there, fed to it as well. And as well as there's also one that goes to the GPU, which is right here. So it's getting a bit closer. So don't forget, battery is disconnected, very important. So there's that chip I was talking about right there. There's a capacitor right here. Now that capacitor is across the sensing diode which is built into the GPU. Now this chip, I did actually find the specs out for this, and it's got two like transistors basically, which are wired up in a configuration opposing each other. So with polarity one way it will detect one sensor, polarity the other way will detect the other sensor. That's the way it works, right? So you actually have, across two lines, you can have two sensors. It's only using one sensing line for the GPU. And that's in parallel with this capacitor. So if I measure across this capacitor here, I should be able to measure the GPU diode. In theory, I could be completely wrong about this. Okay, this is all purely theoretical at this point. But my plan is to get another diode and put it across that capacitor. This is right by the GPU, so it's still going to get warm, and I'll thermally couple it as well. I'll put some some compound on there to thermally couple it as well, so it still senses temperature. That's the plan anyway. So diode mode. So one way I should get basically open circuit, the other way I should see a diode drop. In theory, again, this is purely me testing out an idea. Here we go, 0.655. So that's diode drop one way. Swap around the other way. There we go. That's typical forward reaction with diode. So if I put a silicon diode across here in the same polarity, what will happen is if the GPU breaks connection with the sensing diode, this one will take over. Right, so it's 0.656. Let's find a diode. So I've got two choices here. I've got a 2N3904, which is actually specifically mentioned just over here. No, there's a 2N or something else, but it's little service mount packages there, transistor package. That device is specifically mentioned in the data sheet for that chip as a temperature sensor. Okay, so I could use this device, although it's fairly big. I've also got some 1N4148 diodes over here, like mini MELF diodes, which honestly they're actually much smaller. There's not much in it. So let's do some measurements across here and see what we get. So I get a 0.634 there. So that's one way. And we've got this device, turn it around. 0.5. Right, so this is reading slightly lower. They couldn't see very well. Maybe I should try probing this differently. Let's try and get it here. It's not the easiest thing to try and probe. Come on. Other way around, of course. 0.53. So this is reading slightly lower. This is at 194.148. So it does mention this device as the this 2N3904 as an option in the data sheet for a sensor. So I think I probably should just use that device. And see, as there are similar sizes, which you can probably barely see, pretty small things, but not small enough. Okay, instead of diodes as basic same size as a transistor, but the transistor will work as well, because a transistor works like a diode junction. They have two diode junctions on them basically. So I could either use a diode or the transistor. It's close to real what's going to fit in there best. It's not a lot of room. The transistor gives closer readings to the original, which is probably the benefit is to go to this one. So let's just have a look. Put it to one side for now. Can I make this fit here? Now this has all got to be quite low profile. I can make it stand up a little bit. I might be able to run some jumper wires, put on top of the chip maybe. Could do something like that. It goes to pins 2 and pin 3 of the chip. I could literally just stack on top of the chip like that and run a couple of little wires down either to that capacitor or to the legs of that chip. So I think that's probably a way I'd do it. It's pretty fine work. And if I did the same thing with this diode instead, I mean you can see how much bigger it is compared to the capacitor. You know, I did a step it across the capacitor, but it ain't going to work, is it? It's just way too big. Can I stack it on top like that maybe? Get one leg there and then run the other one over? Probably not. So I think sticking it on top of the chip here, running some wires over would be the trick to do. So I might just give that a go. So I think I need to like attach that on there somehow, then run those wires over. But you have to make sure I get the correct polarity, because if I get the wrong polarity it won't work. That's the other thing on this jigsaw. Now another thing you can actually do, it's an option if you have spare boards, like I do. I'm actually very tempted to do this myself. You've got these original temperature sensors, right, these transistors here. There's one there, and so there's one over the other side by the LVDS connector over as well, just over here, right there. Now those are transistors as well basically, but they sense temperature too, they're used in the same way. And if I do the same probing technique on this one, I'm getting 0.616. Okay, if I do the other one, 0.616 as well. They are also possibilities. If I used one of these devices instead, I could get one of those because they're much smaller. I could probably stack it directly on top of the capacitor and just solder it on. I'm actually very tempted to do that and grab one off on a broken board rather than using a 2N3904. I mean, yes, this will work, but it means wiring it in. I think it'd be easier to use a junk board and get a sensor off that. So I'm going to try and take this chip off here. Hopefully I don't lose it. And I'll try and place it over the top of that. Now I'm going to do this without using a microscope, which is always a bit of a challenge, but not impossible. So let's give it a go. Once I get this one off, I'll put some fresh solder on here as well and that sort of stuff. Right, there's the part. Put that to one side. Because I need to test it to make sure I get the polarity correct. I've got to try and find it again first. It's there. You can see it? Let's move this out of the way. Okay, let's see if we can measure this thing without freaking it off. Here we go. Right. So positive is the left leg, which you couldn't see because it's so damn small. So with it facing this way, there's a leg here, there's a leg here, and there's a leg here. Alright? So it's the top left, or if it's leg here, leg there, it's this one here, which I'll need to solder onto a positive. So it's in the correct orientation right now to go onto this board. So I need to get my iron turned on and get it running. I'm not going to use hot air for this. Move that over here. And I'll need some flux and some fresh solder. Now a little tip, check the battery connector, because sometimes they really self-align themselves and they pop themselves back in again when you're working on it. So always make sure it's tucked out the way. Ideally you take the battery out completely, but sometimes it's not very practical. So get my iron, push some leaded solder on there first, get it started. Right, just like that. And let's try and put the part on there and solder that down. Pretty small, isn't it? Now I'm going to spin this around so I can work on it a bit easier. Always a bit closer to me. Now the other leg of the transistor I need to make sure is not touching anything else as well. I may have to get a microscope out, it's pretty damn small. We'll give it a go. That might be it. Can't quite see. Let me get my visor. This geeky thing here. Have a close look at that through this. It's not quite sitting right. The third leg, which I didn't want to touch anything, is sitting down. I'm going to have to get a microscope out, this is ridiculous. I can't see what I'm doing. It's hard enough as it is. You know, you can see a bit better at least. I'm going to try and do it this way. I'm kind of backwards to where I want to be as well though, so we'll see how we go with that. Make sure the battery connector's pushed out the way again, in case I push it in. Now you can see just here, there's the part. So I kind of need to stick this on those legs like that, but with this end not touching anything. So it's a little bit tricky. I'm kind of backwards to what I want to be. So yeah, not the easiest thing to do. And if I fold it upwards, that might allow me to get onto it. Let's try that, shall we? Fold it over backwards like this. Problem with this is I can't really see in stereo vision, and it's sticking to the tweezers. Oh, come on. Right. Let's try it this way. Come on. It's almost right. I can get that end to solder on. I'll be happy. So just bridged it. That's fine. I can fix that. I reckon. More flux. If in there, add more flux. I might have to use some solder wick. You see the legs, they're not quite right. Slightly offset to one side. Let's fix that before I disturb it too much. This is very, very small work and requires a rather steady hand, which I don't really have. Well, it's melting, it's not moving, so maybe it's alright. Maybe it's on there. Okay, let's get some wick. There we go. Right. Is that one there right now? I'm still not sure about this being attached well enough. Fiddly work. There we go, that's better. Right. Nearly there. Where's the solder gone? Here we go. Yep, that seems to be on. Cool. So now I'm going to clean it up and put some UV curing solder mask in that area to secure it all so it doesn't wobble around, and make sure it's all nice and stable. You don't want it wobbling around everywhere. You have to be careful not to get any fluids dripping through onto the screen or anything like that, because you could end up destroying the screen. So I'm just doing the minimal amount possible. Right, so a close look at that. Does that look alright? You can see it a lot better now, can't you? Let's try and get it on camera. Where has it gone? I've lost where I am. It's over here somewhere. Over here, there we go. Right. Go on, focus on that. Yeah, you see it standing up, it's not touching anything else there. So let's have cocked something else up, we'll see. Okay, you see it's not touching anything it shouldn't be touching. So that's all good. So we're going to put some UV mask on that, cure that up, and that should do the job. Hopefully, I mean time will tell, it may be absolutely no good. I could test it before I put the UV mask on, but the UV mask can be picked off quite easily, so I think I'll do it anyway. I should test first, shouldn't I? What do you reckon? Yes, test first. If I don't, something's going to go wrong, isn't it? I should be able to get a normal reading from that. So let's plug that back in. Plug the charger back in, just for the sake of completeness. This fan's spinning, at least it's not dead. We'll try and boot. Try and speed this process up slightly. I think I need to actually set the boot disk, because it takes ages to find the disk. So I think I actually need to go in there and set it as the selected disk. Haven't got around to doing that yet. So far that's normal. Let's go in and turn that setting on for the monitor for the GPU usage. Energy saver. It's automatic, so it's on the GPU sensing. What do we get now? GPU 35, so it's no different. Okay, so that is exactly what we expect to have. It hasn't affected it negatively at all. So that's exactly what we want. Shut us down again. Actually, I should change that boot disk, shouldn't I, to try and speed up this whole process of trying to start it up. Where are we? Start disk. Select that disk. Do that. That one there. Okay. Close. Now we'll shut it down. Hopefully next time we'll be quicker next time. Okay. Fans are stopping. That's done. Great. Pull this off. Put the battery out just to be safe. So I've been tying up all my surface mount devices and putting them into these cases, these Boxall cases. These are working really well. Bought a whole bunch of them for a little while ago, and only just got around to actually sorting them out. So we want some UV curing stuff. Now, most people say, "Oh, you always use the colour that matches the board." Well, what I tend to do actually is a little different to that. Is I use a colour which highlights to me where the work's been done. Alright, so I use a bright colour. I'm using orange or yellow, whatever it was. I don't know. Anyway, I'm using a bit of this stuff. So let's just get some on this. Put a blob on here like that actually. Just a little blob, just like that. Done. Okay, completely covering it. It's probably a bit too much actually. I think I'll take some back off. I always put too much on. Always. Every time. Let's take a bit of that off. I don't want to make too much of a mess. What I'm trying to do is secure that part so it stays there. Right. So let's cure that. I think that'll do. UV torch. Well, it's actually UV laser. So, don't look at it. Well, you should be right anyway. I mustn't look at it. Got way too much on there. Way too much. Anyway, doesn't matter. It highlights that I've done some work on that spot. Just wait for this. Change angle. I did have a little UV torch as well, which I had been using, but it took ages. It took, I don't know, 4 or 5 minutes. And so I picked up this thing, which is supposed to be a UV laser. So in theory, it should be a bit faster. I've only used it a couple of times, and both times it did seem to be significantly better. Let's just give it a little test, see if it's done anything yet. See, it's already gone hard. So that's already gone off there. Yep, I'll just give it a bit more, make sure it's going right through it. That's looking good. So significantly faster. So if you can get a UV laser, then get one, because it does make a big difference to how quickly this stuff goes off. Well, I think that's pretty good now. I think the colour's changed slightly too, actually, hasn't it? Anyway, maybe. So that'll do. That'll be cured. Job done. So in theory now, that should stop the GPU from slowing down the machine when it glitches, when the thermal sensor plays up. Time will tell whether that works or not. I think it will work, but I'm not 100% sure. So that's a nice little trick, I suppose. If you, hey, if you've got a problem, which is if you've got a machine which is doing that, slowing down, slowing down a lot from the GPU, and you know it's definitely a GPU sensor which is causing the problem, a thermal sensor, then do what I just did there. Get another thermal sensor, strap it across that capacitor, and go from there. That should be what we need to do. So you can see the final result there. Now I should actually tell you what these parts are. Now, this is U5550. That capacitor strapped across is C5551. Okay, so C5551 is that capacitor right there, which is what I bridged across with that sensor. And the one next to it is C5552, which goes to the other sections here, like these fin stacks. Right, it's supposed to go to those sensors. Right, so C5551, strap the sensor across it in the correct polarity, and that should now replace the GPU sensing, the internal GPU die sensing if that breaks. So if the GPU die falls over and stops reporting a signal, stops reporting a temperature, where it goes open circuit, this diode here will replace it instead and still report a temperature from the GPU just in the proximity instead of on the die itself. So that's the theory anyway. I mean, this is the GPU right here, so it's still going to be getting temperature. Fingers crossed it works. If you like this, make sure you give us a subscribe and thumbs up. Share the video if you think people will be interested in trying this hack out. See if we can work around this GPU sensor problem. Make sure you share it. Put it around there. I don't know, Hackaday might be interested, who knows. Share it at Hackaday, that'd be good. Whatever. Try it out. If you've got this kind of setup, you can work on these MacBooks and you've got this ability to try that. Get a sensor, strap it across that cap, give it a go and see how it turns out for you. It might solve the problem. I think this will solve the problem. In theory it will work based on a data sheet for that chip and that sort of stuff, and the way it works, it's just a thermal diode. It measures the diode junction, that's all it's doing. I'm waffling a lot, aren't I? So yeah, make sure you share the video, give us a thumbs up, really important to give me a thumbs up. If you're not already subscribed, make sure you do subscribe if you want to see me doing these modifications, electronic repairs, that kind of stuff. I do a lot of repairs, and anything like this I may tinker around with, I might get an idea and I'll try tinkering and trying something out, and you never know, you might learn something new. That's the plan. And if this fails, as I said before, you've always got these things you can get. You know, they will do the job, that you have to bypass the GPU completely. The downside from those is that you lose the DisplayPort connection on the side, they won't work anymore. Doing this, if it's only a thermal sensor problem, no other issues showing up, only thermal sensing, then you might as well give this a try and see if it works for you. You might get lucky. So yeah, catch you around. I'll see you next video. We'll do something different next time. Bye.